Alright, so this video is to finish log equations. We've already started working with log equations, but these are just a few more examples that kind of show some other opportunities, like when there's maybe not base 10 and there's base 6 like below, or there's multiple logs, or there's no logs, and just using all of our rules together. So it should be pretty simple. There's 4 problems we're going to do together. Please be sure that you are taking notes on these because not only is it a homework assignment, but it is really helpful for your understanding if you're going along with me on these problems. So let's start. First, I've given you just a reminder of all 4 of the log rules: the product rule, quotient rule, and power rule. And then over here, the change of base rule, which is where we could change log base A of B to be the log base 10 of B divided by the log base 10 of A, like this. All right, so let's start on this one here. Solve for x. Round your answer to the nearest hundredth. All right, well, I see log base 6 of everything, which is great, which means these are all kind of like terms, and I can combine them. So I see the log of one thing here minus the log of another thing here. So when I see subtraction, I know that I could go back and use the quotient rule. So I can combine these two on the left side by making this the log base 6 of, and turning the subtraction into a division. So on here it says x minus 10 over 7. So those were the 2 things we were taking the logs of, x minus 10 and 7. And so we could just use the quotient rule and change subtraction to division. Then this over here didn't actually change. Oops. The log base 6 of 23. All right, so now what we're going to do is just like if we had something 1/2 equals x over a half, because these denominators are the same, we can cancel them out. Well, it's the same thing here. If we take the log base 6 of something and it should be equal to the log base 6 of something else, we can literally drop them. So now I have x minus 10 over 7 equals 23. Sorry, that's so sloppy. So I have x minus 10 over 7 equals 23, and I have no logs anymore because I could cancel them out. So now I can just solve it like I would any other equation. So I'm going to go ahead and multiply by 7 on both sides. These cancel out, so I have x minus 10 equals, well, 23 times 7 is 161. And I add 10 to both sides. And x equals 171. Done. Not bad. Basically what I did was I made sure that if I could combine anything using our rules in the beginning, I did, and then I just tried to solve like a normal equation. If I have 2 sides saying log base 6 or log base anything that match up on both sides, then I can drop them. This one here, example 2, is not going to have that option though, because on the right side here you can see that it's not being logged on all 3 terms. There's log base 3 of negative 5x minus log base 3 of 10, but then equals just 1, not log of 1. So I'm not going to necessarily be able to drop the logs, but I still can combine the left side here, log base 3 and log base 3, and I see it's a subtraction, so I can yet again use the quotient rule. So I can write this as the log base 3, that's a 3, guys, sorry, the log base 3 of negative 5x divided by 10 equals 1. With that being said, I could then even simplify if I wanted to. Negative 5x over 10, well, that's the log base 3 of, well, negative 5 over 10 is just like negative 1/2, and then still x. And now I have to figure out, well, how can I drop the log? Well, I can't just drop it like example 1 when they was on both sides here. But I do know that I can use my little exponential form circle and change it. So I could say, well, this is actually just asking 3 to the first power equals negative 1x over 2. Well, 3 to the first is just 3, so I can cancel that out. And then if I wanted to solve just like an equation again, I would just multiply by 2 on both sides. That's 6. Divide by negative 1. Divide by negative 1. And I get x equals negative 6. Great. Let's take a look at another one. Log 4 plus log of 2x equals 4. Now, I don't see any bases, and if I remember correctly, no base really just means it's a log base 10 of something. So, what I can do is, again, treat these two here as that they are like terms. They both have log base 10, so I can combine them. Now, this time they're adding together, so I can use the quotient rule. Product rule, and say, this really is the same thing as being able to combine 4 and 2x by multiplication. And 4 times 2x is actually just 8x. So now I have the log of 8x equals 4. Great. Well, again, this is a base 10, but it's imaginary, where we don't have to write it. And just like this previous example, I can always use my circular exponential change if I wanted to when there's only one log, to get rid of the logs, because I can't drop this without doing something different. So I'm going to take this 10, raise it to the power of 4, and equal it to 8x. So 10 to the 4th power equals 8x. Well, 10 to the 4th power is a large number, but I know that I can just divide it by 8 to solve for x. So in my calculator, I could do 10 to the 4th power first, push enter, and then divide it by 8. And you should get 1250. And I'm done. Let's take a look at the final example here. 3 times 5 to the x minus 7 equals 48. Well, the directions told me in the very beginning to solve for x. Well, this time there is no log involved. So what I can do is at least try to say, well, here I see that the 3 is multiplying by everything on the left, so I can divide it away, because that would get me just 5 to the x minus 7 power. And then 48 divided by 3 is 16. But still I don't have any logs. I need to solve for an exponent. I know that logs always get me answers that are exponents. So what I could do is bring the log in, but if I do something on one side of the equation, that says log, sorry. If I do something on one side of the equation, let me just do that again. That was terrible. If I log the side on the left, I also need to log the side on the right. So, if I'm going to say log of this, I also need to say log of 16. So my new line should say log of 5 to the x minus 7 equals log of 16. That way I'm not changing the value, I'm keeping my equation balanced or equal. So this is great news, because now there are two things that could happen. One, I could use the power rule, because the power rule says that if there's an exponent being taken the log of, I can bring it down and in front and be multiplying it by everything. So if I go back to my original, or to my equation here, well, this really could be x minus 7 could come down in front. So I could say this is x minus 7 times the log of 5 equals the log of 16. This is great because log of 5 is just a number. So if I want to get rid of it, all I have to do is divide by it. This is great because log of 5 over 5 is 1. And now I'm getting closer to having my x isolated. Okay, so I'm dividing by that. Now on the left, I just have x minus 7 equals the log of 16 divided by the log of 5. And now in order to solve for x, all I need to do is add 7 to this side and add 7 to this side. If I do this in my calculator, I say the log of 16 divided by the log of 5, push enter, and then add 7. You should get approximately, and it says round to the nearest hundredth, so I'm going to stop at 2 decimals, 8.72. And I would be done. And that's my answer. There are no more examples. We're going to work on this a bunch this week in class, and then we have an exit ticket on Friday. Cool.